Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so this is a pretty straightforward problem. We are told that we have two wires, two coils, two wires with coils wrapped around them, and they have the same magnetic moment. So what exactly does that mean? So we have our equation for torque. Tau is equal to N, the number of turns, times the current, times the area, times the magnetic field sine of theta. B sine theta. Now we're told that they have the same magnetic moments, which is just this part here. So we can eliminate half of the equation right off the bat. And because we have two wires again, we have two cases, case 1 and case 2. And 1, I1, A1 is equal to N2, I2, A2. I2, A2. So what is the area that we're talking about here? If we have a circular wire, so wires have a circular cross section, which, like this, will have a radius from the center of the wire. So this is the wire in 3 dimensions, and this will have coils going around, wrapping around both sides. So the number of coils we have packed in here is N. That's where this N comes from. The radius is what gives us the area. So each one of these rings will have the same area, which for a circle is pi r squared. Pi times the radius squared. And if you multiply that by N, we get, that's how this total torque here is calculated. That's where the force comes from. So that's what our A is equal to. That is the area per cross section, pi r squared. So we have a radius 1 and a radius 2. So we're given everything we need here. We're given N1, I1, A1, or we're given the radius, we can calculate that. And we're given N2, I2. And we need to find what the radius for the second wire is. So we just have to divide our A's up into pi r1 squared. So now the A is gone and it has become this pi r1 squared. This A is gone and it has become pi r2 squared. 2 squared. So we need to find R2. We can actually cancel the pi's out because we have a pi on each side. If we divide both sides of the equation by pi, they'll both cancel out. So our R2 that we want is just straightforward plugging in all the values that were given. So we need to divide both sides by N2, I2 and take the square root. We can do that all in one step here. Get rid of this r squared. So we now have the square root of everything. We have this whole side here. And 1 I1. We've canceled the pi's on both sides, so we don't need to worry about those anymore. That's R1, the first wire's radius, squared, divided by N2, the coils on the second wire times the current in the second wire. All this is under the square root sign. And that will give you your radius for the second wire.